Good morning. Now here today we are going to see the moment of inertia of some sections which we require in bending stress and shear stresses. Now in bending stress and shear stress you can see in playlist, and in that playlist you are with the strength of materials. Now we have first determined the moment of inertia of this section. Rectangular section we have, and we have given BD be the dimensions, and in that case we will get y bar as it is symmetrical. So my y bar value will be at center, which will be d by 2, and my value of I, that is I will say xx. So we have this will be xx, and this will be at d by 2, and we will have Ixx equal to BD cube by 12. So these are standard actually figures. Now if I will go to the circular section, then I have d be the diameter of this. And then if I will see y bar, then y bar will be at d by 2 from top or bottom, as it is symmetrical. So it is d by 2 from top. And we know moment of inertia along both axes actually in this, we have that is equal to pi by 64 d to the power 4. So these are standard cases. Now we will go with T sections. So we have T sections. This is known as flange. So this part we have flange. And this part we have bed. Now dimensions are given. We have given flange, that is 100 mm, and this is 20 millimeters. Then this is 120 millimeters. And this we have 20 millimeters. And we are interested to find I. So this is not symmetrical, so we have to find value of y bar, which is equal to summation ay bar upon summation a. Now we have y bar equal to summation ay bar. So first we will go with flange, this portion. So we have 100 into 20, we are taking moment about top, and so we have this value as 10 millimeters. Center of this, so into 10 plus. Now we have second this, we have to take moment about top and from center of this. So from center. Now we have this as 60, and therefore we have below 60, center we have 60 from top and bottom. And from top, this distance we require 60 plus 20, which is equal to 80 millimeters. So we have 120 into 20 into 80 divided by, we have 100 into 20 plus 120 into 20. And from this we will get value of y bar, that is equal to 48.18 millimeters. 48.18 millimeters. Now we will go for I. Now we have formula for Ixx. You can see this now. So we have now this value. If I will rub this portion, then we will have this as value that is from top. So we have this value that is now 48.18 millimeters. So I will just rub this portion so it becomes easy for us to understand the things. So this is 48.18 millimeters. So now we have BD cube by 12 plus A into H square. Now first we will go for this flange portion. So we have 100 into 20 cube by 12 plus A into H square, 100 into 20 into H. H is distance between center of this to this X bar. This is X bar, neutral axis, I can say neutral axis. So distance between these two, so we have this distance And this will be 48.18 minus this y bar, which we have taken to calculate y bar. So we have 48.18 minus 10 whole square plus, now we have for this width, so we have B20 now, D we have 120 cube by 12, and A into H square, we have A 120 into 20 into H. Now we have center of this somewhere here, which is 60 from here, and then total we have 80, sorry, 48.18, and this is 80, so we have this 80. So we have to subtract 80 minus whichever is greater, we have to subtract other value from it. So 80 minus 48.18, so just I will rub this. So 48.18, and that is square of this. So 48.18 square. And from this we will get this value, that is equal to, I will write each term separately, 66.67 into 10 raised to 3 plus 2.92 into 10 raised to 6. If third digit is 5 or greater than 5, increase the second digit by 1 plus 2.88 into 10 raised to 6 plus 2.43 into 10 raised to 6. And then from this we will get 8.30 into 10 raised to 6 millimeter to the power 4. So we have, this will be my value of Ixx, that is moment of inertia. So try to understand this. H value, this is H is y bar minus y. Now this y we have 10, if it is greater, or you can have this mod and the square of this. So we will get this value because this is distance between the centroid of the whole section. This is centroid of the whole section to the centroid of individual section. And we have two distance between the two, so it is always positive, and the square of this. Then I will go to this I section. So we have this I section, and we are interested to find moment of inertia for this. Now keep in mind, when it is symmetrical with center, my y bar value will be at center of this section, 95 millimeter. Because you can see total we have 150 plus 20 plus 20, that is 190, and total height 190, symmetrical, and it is half of this, so h by 2, and it comes 95 millimeters. Now here I can directly go, I is equal to capital BD cube by 12 minus small bd cube by 12. Now capital B and D, now we are going to be consider this as whole section. And therefore we have this capital B is 120, capital D whole height, this value. So we have this as 190. And B we have 120. So we have 120 into 190 cube by 12 minus small b, means now I will just hatch the portion by other color, so you will understand it very easily. We have to subtract this portion. Here, when it is symmetrical I section, I need not require to calculate y bar and I bar. So now I have b value, this value, plus this value. So I will subtract 15 millimeters from 120. So we will get it as 150 minus 15. This is B into D. I have, sorry, 120 we have. This total is 120, and we have to subtract this 20 millimeter from this. So 120 minus 15 into D we have 150 cube by 12. And we will get this value of I, that is equal to 39.06 into 10 raised to 6 millimeter to the power 4. So try to understand when we have to calculate value of y bar. If it is unsymmetrical, then we have to calculate y bar. Then we have this, I will have this section, and we have this will be cut of the circular cut is taken of 100 millimeter diameter, and we are interested to calculate value of I of the hatched section. Now again we have to go for y bar, that is equal to summation a y bar upon summation a. Now we have first whole rectangular section which is b 150, d we have 200. So 150 into 200 cube by 12. Sorry, we have to go y bar. So we have summation a y bar upon summation a. I am directly calculating actually I. So first we have to go for y bar. So summation a y bar, that is equal to, first we have rectangular section 150 into 200, and from center, as it is symmetrical with that center, so it is 100. Now we have to subtract a circle from this, which is pi by 64 into d to the power 4 multiply by. Now again from top we have 100 because both are symmetrical with center. So if we will see, my value of y bar should be 100 millimeter over here. And therefore we will get this value if we will calculate. I am just showing you pi by 4, sorry, pi by 4 into d to the power 2. So pi by 4 d square into 100 divided by 150 into 200 minus pi by 4 into 100 square. But as it is symmetrical, both are symmetrical with center, if you calculate this, you will get this value as 100 millimeter because it is symmetrical with center. And therefore I can directly go with this, that is bd cube by 12 minus pi by 64 d to the power 4. Now why? Because h value in both the cases you will get 0. And therefore second term ah square you will get it as 0. So now we have b 150, d we have 200 cube by 12 minus pi by 64 into d we have 100 to the power 4. And we will get this value 95.09 into 10 raised to 6 millimeter to the power 4. So here we have to actually keep in mind this is area and centroidal distance from top again 100. So likewise we have to calculate value. So if we will calculate, we will get this as 100 and same again. And then last problem we will have. Now I have taken this as eccentric, and in this case we have to find y bar. So now again y bar we have 150 into 200 into 100 minus, now area of this pi by 4 into d square, and we have actually given this distance from bottom, this is given as 25 millimeters. Then we have this value 50 millimeters, and top total, sorry, this is 200. So 25, 50, and again this we have 25. So we have 50, 75, 100, and below again we have 100. So we have pi by 4 into 50 square. Now from center of this, we have distance 25 plus this 25, this becomes 50. So into 50 divided by 150 into 200 minus area of this pi by 4 into d square. And from this we will get value of y bar 103.51 millimeter. It will shift downward because we have cut in upward portion. And now I we have bd cube by 12 plus a into h square. If any calculation mistake, you can please communicate. So we have 150 into 200 cube by 12 plus a 150 into 200 into h. Now we have this as 100. So we have 100 sorry, 103.51 minus 100. So 103.51 minus 100 whole square plus, sorry, now we have to subtract this. So we have this as minus, we have due to circular section, we have pi by 64 into d4 plus a into h square pi by 4 into 50 square into 103.51 minus, now we have 50. These values we are taking. This is 50 and this is 100. And from this we will get this value that is equal to, first value we will get 100 into 10 raised to 6 plus we have second value that is 150 into 200 into 103.51 minus 100 whole square. So this comes 369.6 into 10 raised to 3 minus, in bracket we have this value 22.8 into 10 raised to 6. And from this we will get this value that is equal to 100 to the power 6 plus 369.6 to the power 3 minus 22.8 to the power 6. And it comes 77.57 into 10 raised to 6 millimeter to the power 4. So whenever you have cut in these sections, you have to go likewise for your moment of inertia. So now we will stop here only. So thank you.